We're going to be taking a look at the inverse of complex numbers. And by this, I'm talking about 1 over z, right? Obviously, where z is a complex number, where z equals x plus I, y. Now, how would we go about solving something like this? Well, a move that we can do when we appear to be stuck is to just go ahead and multiply by 1. And you might say multiplying by 1, that doesn't seem like it's going to get us very far. It's actually going to get us really far, right? We're going to be multiplying by the conjugate of that complex number over the conjugate of that complex number. And you might say this looks like it's against the rules, but you are always allowed to multiply by 1. You are always allowed to multiply by 1 because we have the same numerator and the same denominator. What do you get when you divide 3 by 3? You are going to get 1, and you're always allowed to multiply by 1. You are not affecting the result. You're just going to be making it easier to solve the problem. You can do this whenever you want. You're always allowed to multiply by 1. You can do it at a birthday party. You can do it at a graduation. You can do it at a funeral. That last one would probably be a bit disrespectful, but you can still multiply by 1 and not have too many people mad at you because you're allowed to do it. If you divide by 0, that's another case, then people will be mad because the universe is going to end. So we're going to do this here, and the reason we're going to do this is because it's going to be making it easier to solve. We will have, on the top, we'll have the conjugate of that complex number. On the bottom, we will have the complex number multiplied by its conjugate. Now we want to go ahead and just write these out for what they really are. We know this one on the top, the conjugate of z is going to be x, which is a real number, subtracted by I, multiplied by y, which is a real number. On the bottom, we learned about this in the last video, right? We saw this here, multiplying a complex number by its conjugate is going to give you a real number, right? We saw that, and that real number is going to be x squared plus y squared. If you're wondering how we arrived at that, check the last video, and really it's as simple as just substituting z for what it is, which is x plus iy, and then substituting z conjugate for what it is, which is this term up here, and then just multiply them out, and you're going to get x squared plus y squared. Remember, you have to substitute that I squared for -1, and you'll be able to arrive there. So we can go ahead and rewrite this. Go down here. We will write it as it is, so x minus iy over x squared plus y squared, and that is what we're going to get. And then we can go ahead and we can actually split this up even further. So if we want to split this up even further, I'll show you what we're going to do. Let's get a new color. Let's go with what haven't I used so far? I got some magenta or whatever. So if we go ahead and just split this up, we can go ahead and we notice that we keep the denominator the same, and we can split these up over here. So we'll have x squared plus y squared. Ooh, my computer is going very slow, so I'll try to wrap this video up quickly. Subtracted by, we're going to keep the I on the outside, and then on the inside we will have y x squared plus y squared. And what do we notice? What do we notice here, right? Well, we have two things that we can call real numbers. This here has a real number on top and real numbers on the bottom. This will be a real number. This one here inside, not including this I, so if we were to put brackets over here, this would also be a real number. And essentially we're just looking at, if we're looking at this right now, we are looking at a real number subtracted by I, and then you have y over x squared plus y squared, which is a real number. So essentially all this is showing us, because we have that same format that we require for the complex numbers, it's showing us that division is possible. Division is possible with complex numbers. So that's all we're going to look at with regards to the inverse of complex numbers. If you have any questions regarding this, leave a comment below and I will respond to you as soon as I can. Thanks for watching.